Okay, so hi everyone. We are going to start in a while, and the topic of today's discussion is algorithmic differentiation for quantitative finance. Okay, so let us first understand what algorithmic differentiation is. So it's just, as the name appears, is a way to differentiate any particular function, right? Now, as you know, differentiation is something that appears everywhere in quantitative finance, starting from quant trading, right? So, for example, when you are creating a strategy, trading a strategy, there you are calculating risks, right? For example, you might be calculating delta and gamma and all other things, right? Similarly, in quant risk, you might be calculating the exposure of the portfolios, their sensitivities. So for all these stuff, you will be differentiating, right? Now the problem is that there you won't be having single. So in general, for example, let f be a function of f of x. Here, if you want to differentiate, it's easy. It's not that easy because f, it also depends on f what kind of function f is. But for example, f is a function having 1,000 variable, right? Up to 1,000. Now, in that case, you can understand how difficult it will be to, for example, find out these sensitivities df by dx1, dx2, dx3, right? df by dx, and all that. So, and so there are particularly two methods that I think you might be aware of. First one is obviously symbolic differentiation. What is symbolic differentiation? Symbolic differentiation is nothing but what is symbolic one? So let us say f is sin x, right? For example, sin x plus y. Then df by dx will be simply cos x. And then suppose I want expect you to find out it at f of d of by dx at x equal to pi by 2 and y equal to 0. Then you will be putting this value and finding you will find out df by dx at this particular x and y. Okay, so this is symbolic differentiation. So first you find out the closed form, which is this one, right? Closed form, and then you put the values. Now you can understand how difficult it will be to write it in code, right? Symbolic differentiation, first of all, you need to write the expression. So basically, if you are coding it, then you need to write the expression. Now, if the closed form is very difficult, but if the function is difficult, it will lead to problem. So computational efficiency is one of the concern in the symbolic differentiation. Now let's talk about the finite difference approach. What is the finite difference approach? Can anyone tell? Finite difference approach is the another way to find out these derivatives, right? So in the last example, df by dx, the finite difference approach will be this, right? Anyone? Everyone agrees with it?
Yes.
At a constant y, obviously at a constant y. So if I may write explain it in this way, so f of x plus h at a constant y. So this is finite difference approach. Now the issue with the finite difference approach is precision, of course, right? The accuracy that you are getting. I hope you know that if you are doing it, you are basically having an error of O1, right? Of delta x basically, which is O1. You can use find it using Taylor's formula, right? Okay. So enters algorithmic differentiation. First of all, it is fast, easy to implement. Okay, and the third one is precision is very much high. That is the machine precision you can achieve. Okay, so that's why we need algorithmic differentiation. So this is the first part. Why algorithmic differentiation? First one, it is fast, efficient, and the third one is precision that comes with the algorithmic differentiation. Okay, any doubt till now?
No, no.
Okay, so in the industry, okay, so I particularly choose this project because it is something that industry uses, okay, a lot in their code, in their implementation. And if you include this in your project, it will be kind of unique experience because I don't think you will find this kind of project anywhere. So that's why, for example, whether you are calculating the sensitivity related to the black holes, try it using algorithmic differentiation. Okay, if you are finding out the risk sensitivities like CVA and all, you can try using algorithmic differentiation. In the end of the slide, I have listed some important uses. For example, you are finding PbO1, DbO1, right? Risk related to SOPs and all. You can do it using algorithmic differentiation. And in fact, in the industry, algorithmic differentiation is used. Okay, so that's why that is the reason of us choosing this particular topic as a project. Okay. Now, what algorithmic differentiation is? That's the question. Okay. So the simple answer is that algorithmic differentiation breaks down a particular function into basic operations like plus, multiplication, exponential, logarithm, a basic decomposition, right? And then we apply the chain rule to compute the derivative. Okay, as simple as that. Now let's start doing it. Okay, and I will show it how it is easy this particular thing is, right? So let us take one particular function z is equal to xy plus e to the power x, okay, plus x by y. Okay. Now, how do you decompose, right? So, for example, let us say the first step is let us try to decompose it, right? Let's try to decompose it. The goal is to find y at sorry. The goal is to find z at x equal to 6 and y equal to 3. How does the decomposition looks like? Very simple, okay. So first of all, I will write down the name of the variable, its expression, and the values, right? Okay. So first of all, I will choose new variable which is m naught. It stands for x, okay. And what is the value of x? It is 6. And then m1 will be denoting y, okay. And the value is 3 because we are calculating it at y equal to 3. Then probably xy is there, right? So maybe we can go for another variable m2, right? M2 will give me m0 dot m1. Why? Because xy is there. What will be this value? 18. M3. Now let us write this one first. So this is e to the power x, right? Maybe it will be e to the power m0 for me. And what will be its value? E to the power 6. Right? Then I will define a new variable which will be m4. Okay. M4 will be this particular sum, right? Xy plus e to the power x. And in terms of my new variable, it will be m2 plus m3. And what will be the sum? 18 plus e to the power 6. And then a new variable again, m5. M5 will be x by y. X by y is nothing but m0 by m1. Okay. And this particular value will be 2, 6 divided by 3. And then finally m6. M6 will be the whole z, right? And what will be its value? This one and this one, right? So it will be m4 plus m5. And this will finally give you the final value, which is 18 plus e to the power 6 plus 2, which is 20 plus e to the power 6. So here we have not calculated the derivative, but I have just shown you that how have you decomposed the z, finding out the process of z using these simple variables, right? So finally, you see now one interesting thing with algorithmic differentiation as well is that you are not storing the variables, right? You are in fact storing the values. So values are getting calculated, and then you are it is getting added, multiplied, or whatever it is, right? So that's one good thing about algorithmic differentiation. So it's not algorithmic differentiation here, but I have just tried to show it how do you decompose a basic variable. I don't think there will be any doubt in this particular section, right? So z at x equal to 6 and y equal to 3 will be nothing but 20 plus e to the power 6. Now where do we need algorithmic differentiation, right? For example, let us say we need to calculate dz by dx or dz by dy. That is where we need to use the AD. Okay. So, for example, we want to find out this particular partial differential or this particular partial differential. Therein, we need to use the AD. Okay. So, basically, there are two methods of algorithmic differentiation. First one is forward method, which is also called tangent mode, and the second one is reverse algorithmic differentiation. Okay, which is also called adjoint mode. Okay, and this is something that is used in the industry because of the time complexity. The reverse mode is more popularly used. But before we discuss the reverse mode, let us first discuss the forward mode. Okay. Great. Okay. Uh, just to show you as an example, we intend to find out dz by dx over here. Then I will show you how we can extend it in a single piece of code. You can find out dz by dx or dz by dy or any set of variables. But first of all, we will be finding out, our target will be just to show you how can we make it easy. So our target is to find out dz by dx. Okay, great. Please let me know in case you have any questions so far. Okay, so this one is the main chart that we will be using. Okay, so again, we are starting with m naught. Okay, our goal is to find dz by dx. So first of all, we'll be finding m naught. Okay, m naught. M naught will be dz. Sorry, m naught will be just a minute. Yeah. So m naught is x, and then we have m1, which is y, right? And we need to find out m6, right? Dz by dx. Okay. So we'll be defining m naught as d of x divided by d of x. What will be this value? So basically, we will be differentiating all this value with respect to x. Okay. What will be this particular value? Dx by dx.
1.
1. And then m1 dot. M1, what will be m1 dot? M1 dot will be d of m1 divided by dx. Okay. D of m1 divided by dx. Can you tell me what will be this value?
0.
0. And then m2 bar. M2 is m1 m0 into m1. D of m0 into m1 divided by dx. Okay. So if you don't have a good grammar mathematics, then I think obviously you will have. So here you have to apply the chain rule, right? So first of all, let us assume m0 as constant, and then you will write m1 divided by dx. And then assume m1 as constant, and then you will write d of m0 divided by dx. What is this particular value? dm1 divided by dx, it is nothing but m1 bar, right? And this is m0 bar. Now, m1 bar is 0, so this particular value will be 0. And this one is m1 into m0 bar. M1, what is m1? M1 is 3. And what is m0 bar? M0 bar is 1. So this particular value will be 3, right? Any doubt? No doubt, sir. Okay. And then m3 bar. What will be m3 bar? M3 bar will be d of, what is m3? E of m0 divided by dx. Again, it will be simple. Again, you have to apply the chain rule, right? So E of m1. This was not chain rule, this was product rule. Apologies for the confusion. And e to the power m0 divided by d of m0 divided by dx, right? E to the power m0 into d of m0 divided by e to the power m0 is again m3, and this one is m0. Sorry, m0 bar. M3 into m0 bar is just m3 itself, right? What is m3? M3 is e to the power 6. Any doubts so far? I think no, right?
No, no, no.
Okay. And then we will go for M4 bar. M4 dot, sorry. M4 dot will be d of M4 divided by d of x. Right? So basically we are differentiating each of the decomposed variable with respect to x. It is M2 plus M3 divided by x. M2 plus M3. So it will be simply M2 bar plus M3 bar. Right? It will be M2 bar is 3, sorry, not bar, M2 dot. So basically 3 plus e to the power 6. And then M5. M5 is M0 divided by M1 with respect to x. Again, you have to use the product rule. So first of all, you will be keeping, or you can use the division rule as well, but I would like to use the product rule. I will be keeping M0 as constant, then I will be differentiating 1 by M1 with respect to x, which will be 1 by M1 square, right? With respect to, and then d of M1 divided by dx. Plus, I will be keeping 1 by M1 as constant, and then I will be differentiating M0 with respect to x, which is d of M0 divided by dx. Right? And this will be, and again, if you see d of M1 divided by dx, which is M1 dot, which is 0, right? M1 dot is 0. Basically, M1 differentiation of M1 is 0. Now we have 1 by M1 into dm0 divided by dx. 1 by M1 is nothing but, sorry, 1 by M1 is already, we know, right? Which is 1 by M1 itself, and dm0 divided by dx is 1, right? Which is M0 bar. 1 by M0 into 1. 1 by M1 is 1 by 3. Okay? And the final is M6 bar. M6 bar is d of M6 divided by d of x. What is M6? M6 is M4 plus M5. It will be M4 bar plus M5 bar. M4 is 3 plus e to the power 6 plus M5 is 1 by 3. So this is the, now what is M6 bar by dx? What is M6, by the way? If you see, M6 is nothing but z, right? So it is nothing but dz by dx. So you see, you have calculated dz by dx by just differentiating all the variables with respect to x, and you have calculated the final answer. You can check that dz by dx at x equal to 6 and y equal to 3 will be this particular value. Okay, got it?
Yes, yes.
Okay, so you can write it in terms of code. Okay, but when you want to write in terms of code, you can see that. Okay, so when you write it in terms of code, you have to particularly specify whether you are calculating with respect to x or you are calculating with respect to y. Okay, so it is always better to calculate in a different way. Okay, so I hope you have understood this particular, the basics of forward mode, right? At least if yes, then I will be showing you how you can implement it in terms of code.
Yeah, yeah, understood.
Okay, so I will write it in terms of so this is a forward mode itself, but for code. Right, again we'll be starting with the basic variable. Okay, but yeah, let me give you one thing. So what we are doing is that instead of writing whether we are derivating with respect to x or whether we are derivating with derivative, finding the derivative with respect to y, we are simply writing dt. Okay, got it? So instead of differentiating any particular variable with respect to x or y, we will be differentiating with respect to dt. Okay, got it? So let us see how do we do it and how it is used. Okay, so the first variable for us is m0. Okay, so instead of finding its differentiation with respect to x we will be differentiating with respect to d of m naught. M naught is x, right? X. So it will be dx by dt. So we are not, finding derivative with respect to x, right? Because we are not specifying whether we want to find dg by dx or dg by dy. We are just saying that we want to find it with respect to any variable t. Okay. And then m1 bar, m1 dot, it will be dx. M1 is y, so it will be dy. So we'll be differentiating all the intermediate variable with respect to t only. And then m2 bar, m2. What is m2? M2 is m naught into m1, right? M naught into m1 divided by t, right? So what will be this particular? Can anyone tell the expression for it? What will be this one?
M naught into M1 bar plus
Okay, so this will be m naught into m1 dot plus m1 into m2. Right? Talking about m3, m3 is nothing but e to the power m naught into dt. So I think you can easily guess it. It will be this one, right? Talking about m4, what is m4? M4 is M2 plus M3. I will directly write it. It will be M2 plus M3. Okay. Talking about M5. M5 was M naught by M1. Okay. With respect to dt. And it will be, first of all, let me keep M1 as constant. Then it will be 1 by M1 into M naught plus M naught constant. Then differentiating of this one. Sorry, I don't know. This is my habit of writing this. But this is quite dangerous. Then it is, sorry, the differentiation of 1 by m1 is minus 1 by m1 square. Okay. I think I have done this mistake here as well. So please excuse me, this minus should not be here. This square should not be here. This will be here. Not into minus 1 by m1 square, right? Yeah. Okay, so this is correct. And then m1 bar, right? And then finally m6, which is d of m4 plus m5 divided by dt. It will be m4 bar. So now what you see that finally we have calculated this, right? Now let me tell you what you have to do. So whenever you define the function, right? Whenever you define the forward function, for example, in terms of Python, if you are doing it, define a forward mode, right? First of all, you will be obviously specifying the x value, y value, right? And then you have to specify the x1 bar, x bar and y bar. Okay. So this is nothing but your x bar and this is nothing but your y bar. Okay. So for example, you want to calculate uh, dg by dx. Then what you will be doing, you specify dg by dy as 0. Okay. So it will become 0, right? It will become 0 and then only all differentiation will be calculated with respect to x, right? So the value that you will be passing, so to find out dg by dx, you will be passing x, y, x bar is 1 and y bar is 0. To find out dg by dy, you will be passing out x, y, this is 0, this is 1. Any doubt? Any
No
doubt?
doubt, sir.
Okay. So this is how we have completed the forward mode. Okay. So I think you all can implement this one, right, in code. Now let's talk about the reverse mode, or which is also called the adjoint mode. So as the reverse mode says, so in this forward mode, why do you think that it is a forward mode? Because you first made the table, right? It is called trace table, okay? In terms of AD, it is called trace table. And once you make the table, you start differentiating from the forward of the table, from M0 only, right? And not with M6, okay? That's why this is something that we call as the forward mode. In the reverse mode, as you can guess, we start with M6, then we find out M5, then we find out M4, then all these stuff, and we go to M1, M0, okay? So that is why we call it reverse mode. We don't exactly find out the differentiation. We find out something called adjoint, which I will be just showing you in a minute. But the reason why we call it reverse mode should be clear to you. Okay. Now let me discuss with you something which is, I think, a part of multivariate calculus as well. So let us say W is are several outputs. Okay, W1, W2, W3 are several outputs, and U is an input, any particular input. Okay, S is any other function. Now, if you want to find out the partial derivative of ds, so partial derivative of S with respect to the input U, okay, partial derivative of S with respect to the input U, then what you do is you write ds by d of W1 into dW1 by du plus ds divided by dW2 into dW2 divided by du ds by dW3 into dW3 divided by du. So what exactly are you doing? So if you want to find it with respect to, if you want to find out a partial derivative with respect to an input u or with respect to a variable u, try to find out, so all those function w which depends on input u will be used over here. So you see that w1, w2 and w3 are those functions which depends on u, right? That's why we have written in this particular form, right? Everyone clear? I think this is the concept that is related to multivariate calculus, and you must have read this, right? So this is kind of a chain rule. Okay. So now let's get back to the original section. Okay. So in case of reverse mode, we try to find out adjoint. Okay. What is an adjoint? Let me tell you. M6 bar, right? M6 bar is called adjoint, and this is the derivative of the output. Okay. So dz is the final function with respect to M6. This is called adjoint. Similarly, what will be M5 bar? This will be dz divided by d of what will be M4 bar? Derivative of the output, which is dz with respect to M. These are called adjoints. Okay. So this is called adjoint of M6. Adjoint of M4. Adjoint of M4. But we don't have to do that. I will show you one particular good method, which is very fast as well and efficient as well to find out the reverse mode. Okay. So let us define a particular function y. Okay. Sorry. Let's define a particular function s. Okay. S. And simply write ds by dz. Z is our output variable, right? Which is m6 in our case. is equal to question mark. We don't know what is the value of dz by ds by dz. Why don't we know it? Because we don't know what kind of function s is. Okay, as of now, let us just it be any secret. Okay. Now, obviously, z is m6, so we don't have to do anything to m6. Okay, let us leave it as of now. Before m6, what is the value? Can we write it? Before m6, we have m5, right? Before m6, we have m5. So we need to find out what is ds divided by dm5. Okay, it's quite easy. What did I say here? Remember this particular stuff. Okay, if you want to find out what is ds divided by dm5, find out all functions for which ms m5 is an input. Okay, m5 is an input to m6 only, right? M5 is an input to M6 only. So M6 is the only output. So we'll be writing it as D by DM6 into DM6 divided by DM5. Okay, got it, everyone? M5 is an input to M6 only. M6 is the only output. Okay, so you will be writing it in terms of DS divided by DM6 into DM6 divided by DM5. And what is DM6? What is DS divided by DM6? DM6 is DZ only. So we'll be writing in terms of dm6 divided by dm5. And what is dm6 divided by dm5? Can you say? If you look at over here, what is dm6 divided by dm5? Partial derivative of dm6 with respect to dm5. Guys,
1.
1, right? So it will be 1. So it is nothing but ds divided by dz, right? So let me write it again. ds divided by dm6 into dm6 divided by dm5. dm6 divided by dm5 is 1. So it is nothing but ds by dz only, right? Because dm6 is nothing but dz only, right? Okay. Now let's talk about ds divided by dm. Again, what you will be looking at, find out all those outputs for which m4 is an input. You will see that m4 is an input to m6 only. Again, you will be writing this particular thing only. So it will again be ds divided by dz only, right? Got it?
Yes.
Okay. Let's talk about ds divided by dm3. What will be ds divided by dm3? So m3 is an input to m4, right? M3 is an input to m4. So we'll be writing in terms of m4. So it will be ds divided by dm4 into dm4 divided by dm3. What is dm4 by dm3? Sorry, let me take a screenshot. dm4 divided by dm3 is 1 only. So this is 1 only. So it is ds divided by dm4, and ds divided by m4 is ds by dz only. Okay, great. Let's talk about ds divided by dm. Can anyone tell me what will be the expression? Please look at this part. What will be the expression for ds with respect to dm?
ds by
ds by
dm4 into
dm4.
dm4 by
dm4 right.
Right. And it will again be ds divided by dm4, which is ds divided by dz only. Right? Now let's talk about ds divided by d of m1, right? What is ds divided by dm1? What is what will be ds
ds
divided by dm? Yes, please.
ds by dm2
dm2 into dm2 by dm1,
into by
right?
dm1
And anything else?
And
And
M5 term will
ds
also
by
be there.
dm.
ds by m4 4 also
M5.
Right. 5, right?
five
Yeah,
five
M5.
Great. So ds by dm2 again is ds by dz only, and dm2 divided by dm1 is m differentiation of m0 with respect to, sorry, m0 1, and so it is m1 m0 into m1 with respect to d of m1, which is m0 only. Any doubt? Because obviously m0 will be constant, right? Now ds divided by dm5 is again ds by dz, and dm5 divided by dm1, dm5 divided by d, so not divided by differentiation, so it is d of m5, which is m0 by m1 with respect to m1, right? So it will be m0 is constant, and then minus 1 by m1 square, and then so this is enough, right? So we can take m0 common, and then it will be 1 minus 1 by m1 square, then ds by dz. Okay, and then finally ds by d of m0. Okay, what will be ds by dm0? It will be m0 is an input to m2 and m3, right? So ds divided by dm2 into dm2 divided by dm0, and then ds by dm3 and dm3 by m0. Okay, so m0 is an input to m5 as well. So this is the one thing I want to iterate over here is ds by dm2, ds by dm3, and ds by dm5. All these values are ds by dz1. So I will take it common. dm2 with respect, so differentiation of m2 with respect to m0 is m2 with respect to m0 is m1, m3 with respect to m0 is m3 with respect to m0 is e to the power m0 only, and m5 with respect to m0 is 1 by m1. Okay. Now here is the magic. Okay, you wanted to find dz divided by d of x, right? What is m0? M0 is x itself, right?
x
So here you see, let us replace s with z. Okay, if you replace s with z, what you will see, dz, that is dz divided by dm, which is dx, right, is equal to dz divided by dz, which is 1. So you have easily find out dz divided by dx is equal to 1 into m0 m1 plus e to the power m0. See, it is dz by dx. Is it the same expression that we got here? Just a minute. See, this is the same expression, right? 3 plus 1 by 3 plus e to the power 6. And here also you have got the same expression. But here you have one more magic. The magic is that you have also find out dz divided by dy over here. Dz divided by dy. Just replace s with z. Okay. So this is the one benefit with the reverse mode. You don't have to find the same function twice. So in case of the forward mode, you will be passing the function value twice, right? To find out dz by dx, you will pass a separate set of value. To find out dz by dy, you will be passing a separate set of value. But this is not the problem with the reverse mode. In a single iteration, you can find out both the partial derivatives. Got it? Now let me tell you how will you write in terms of code. Okay. First of all, you will be starting with this one. This is something that we will call m5 bar, right? Okay, so maybe you can start with this one only. Okay, what will be this value? So S is Z, right? So dz by dz will be 1. So you will be writing as M6 bar is 1. Then you will be writing M5 bar, which will also be 1. Or if you don't want to keep it as 1, you can simply write in terms of variable itself. Okay, but it is all more good if you write in terms of 1. So you'll define variables like M5 variable is 1, M4 bar is 1, and then similarly you will write in terms of other variables, right? So can it be done, everyone? You just have to write in terms of code, and then you have to find out the final value. Got it?
Yes, sir.
Okay. So I think we have understood the forward mode and the reverse mode as well. Apart from that, what we have to do is that we have to understand the time complexity, which we'll be doing in the next session, along with the practical implementation of one thing in the Plexos mode or either so far. But what we have to do is that you take one example. Okay, first of all, you take one example and find out the differentiation in both forward mode and the reverse mode. First do it manually and then try to do it using code. Okay, I will be sharing you one reference material where the code is also written, and in case you have any doubt, you can just let me know anytime. Okay, yeah. So before we end this lecture, let me just tell you, this is the M5 bar, right? ds by dm5. This is M5 bar, this is M4 bar, this is nothing but M3 bar, right? So this is how you have to proceed. So maybe you can write M5 bar as a function, right? This is what you have to do. Got it?
Yes, sir.
Okay. Thank you, everyone. I will share you. I will be sharing you the reference
Kshitij,
material as well. Yeah, please.
hello. Hi, Kshitij.
Yeah.
Yeah, can you explain the last step that after you found out all this thing, you replaced S with Z, no? That step only,
Okay. See.
S is equal to Z, yeah.
Yeah. So see, it's interesting actually. So what we did is here we have got ds divided by dm naught is equal to ds divided by dz into m1 plus e to the power m naught plus 1 by m1. What was our goal? Our goal was to find out dz with respect to dx, right? Now m naught is x itself, so it is nothing but ds divided by dx. This is nothing but ds divided by dx. Now can we simply replace s with z? If you replace z s with z, you will be finding out dz by dx, right? dt will be 1, and then simply m1 plus e to the power m0 plus 1 by m1. Got it?
Okay, okay.
Right? And similarly, in here you will be finding out uh, dz with respect to dy, because m1 is y. Okay. So what did we learn? So in the reverse mode, you are finding the values directly. So dg by dx, dg by dy were found in a single iteration. You don't have to run the function twice, right? But in case of forward mode, you have to run the function twice to find out these two particular values. Okay, got it?
Yes, yes.
And one more important thing is that with adjoint differentiation, now you must understand the difference between the symbolic differentiation. Finite difference approach, obviously the difference is clear. Finite difference method is altogether a different thing. See, the difference between symbolic differentiation and this particular thing is that you are calculating the numeric value step by step, one, and then other numeric values, right? I have not written in terms of the numeric value, but if you see this one, ds by dz is obviously 1, m0 is a number itself, m1 is also a number. So all you are calculating is the number, right? You are not writing in terms of variable, which makes the thing complex in case of symbolic differentiation, right? Are you getting this particular difference? This is very important.
Right.
Okay, so maybe what I suggest you is that I will be sharing the file right now. Try to write in terms of code. Okay, take the required input. In this case also the required input will be m0 and m1 only, sorry, x and y only. The output will be dg by dx and dg by dy. Okay, That's it. So thanks everyone
Hello,
for
Kshitij.
attending the lecture. Yeah, please.
Hello.
Yeah, hello.
Yeah, hi, Kshitij. I have one question that so for every function we have to make a different table like this, and then
Right.
we have to proceed.
Exactly. Exactly.
Okay, okay. So if we like it is not possible for us to write program for a general function. So for
No,
every
no, it
function
will
we have to.
obviously. Right.
Yes,
Exactly. So
yes,
for every function, it will be different.
yes, yes. Okay, okay. Thank you.
Yeah. So what I was telling is that for every function, it will be different.
Yes, yes.
Right.
Thank you, thank you, thank you.
Yes. So thanks everyone for attending the session.
Yeah, thank you, Suresh.
So in 1 week, I expect you to try it in one. So first of all, take one manual function. It may be anything, xy square plus xy or anything log x, anything that you want to take. Try whether you are able to get the forward mode and the reverse mode, whether you are able to match the answer of the correct differentiation at any point with the forward mode and with the reverse mode, both of them, and then try to write a code for that thing. Okay. In case you face any issue, please ask in the group. I am always available to reply. And yeah, in the next week, by the next week, I hope you are able to write it in terms of code, whether C++ or Python. I will be sharing one reference material, and in the next week, we'll be looking up at one practical implementation in the world of quantitative science, along with the time and space complexity as well.
Yeah, okay, sure.
Thank you. Thank you, everyone.
Thank you.
Thank you.